Hi, most excellent rock buds. It's Rock Pop. I hope you guys are doing great. Today's topic, by popular request, is the geology of gold. We're going to learn about where all the gold on our planet is located and how that gold gets up into places where people can get at it. We're also going to talk about how to look for gold, the process of looking for gold, and the different ways that people have looked for gold and processed gold. And as usual, if you like this video and it's useful, please subscribe. And thank you so much to all my wonderful, wonderful subscribers. I appreciate each and every one of you. So here we go, the geology of gold. So just to get started by whetting your appetite for gold, here's some interesting pictures of gold. I'm sure we all have one of these at home. Now here's an ancient, interesting burial. Can you see the little gold object which the writing refers to? Is mankind had its weird moments or what? And here's something we're still looking for. But our focus today is going to be on this kind of gold and this kind of gold. All of Earth's gold comes from its core. In fact, scientists tell us that there's enough gold in Earth's core to cover the surface of the Earth a foot deep in gold. How they know this, I have no earthly idea. So let's take a look inside Earth. The yellow ball in the middle is the core. It's about 1,800 miles below our feet. The red part is the plasticky molten mantle, about 1,800 miles thick. And the thin, cooled top of the mantle is the crust. Ocean crust is about 5 miles thick. Land crust is about 20 miles thick. So how does gold get from the core into the mantle? The answer is heat-driven convection currents that act just like a lava lamp. Mantle material heated at the core expands and rises up, bringing gold and other elements with it to the top of the mantle. Next question, how does gold get into ocean crust and land crust? It does this via rifting and subduction, two old friends. Hey guys, so let's look at the ways that rifting and subduction bring gold up into the crust in areas that man has access to. Rifting and subduction both provide the two main ingredients that bring gold near the top of the crust. That's molten magma and hot water. Where magma and hot water come together, gold can form near the surface. Let's take a look at rifting. Here's a mid-ocean ridge, like our Atlantic mid-ocean ridge, and it's producing ocean crust on either side of the ridge. Do you see a blob of magma? Yes, and this thing is at the bottom of a deep ocean, so there's plenty of water. Water goes down into the rift where it gets super hot. It picks up gold and other elements and then expands and comes back out, putting gold and those other elements into the ocean crust that's being created. Let's take a look at Iceland, because it is a place where the mid-Atlantic ocean rifting ridge comes to the surface. Iceland has a bunch of hot springs where magma below the surface heats up water, and the water picks up gold and other elements, bringing them toward the surface. Hey rock buds, mining companies are starting to focus on the gold in Iceland and in other places along the mid-Atlantic ocean ridge, as well as in ocean crust in the ocean, to see what the possibility of extracting that gold would be. It's going to be expensive, and I for one hope they don't mess up the environment when they do, if they do. But it is subduction that brings gold close enough to Earth crust surface so that we can dig it out and profit by it. You'll likely remember that island arc subduction is when ocean crust subducts beneath ocean crust, creating a volcanic island chain in the ocean. And continental arc subduction is when ocean crust subducts beneath the land crust of a continent, producing a chain of volcanic mountains. And then there's the case of our modern-day Rocky Mountains, where a subducting ocean plate went from 45 degrees angle to flat and produced a continental volcanic arc way inland. Hey guys, the bottom line with these different types of subduction is that hot magma comes in contact with water and they react together to pick up gold and distribute it close to Earth's surface. With volcanic island chain subduction, you have tremendous amount of ocean water going down in the subduction trench. The ocean water gets superheated by the magma down close to the mantle in the subduction zone, and it picks up gold and other elements, rises up, and as it rises up into the ocean sediments, it cools and deposits that gold, lacing the ocean sediments with gold. This black smoker is what does the job. There are lots of black smokers all over the island arc volcano under the water. They're spitting out gold, iron, sulfur, silver, zinc, copper, lead, and other elements onto the seafloor. Next thing that happens is the volcanic island chain is pushed up and smashed up against the continent because subduction creates and enlarges continents. In this picture, each one of the different colors represents a separate geologic terrain, each of which has been pushed onto the continent, and those terrains are separated by fault lines. A fault line is just a smash, crash, and metamorphosed zone between two geologic terrains that have been pushed up on the continent. This crashing process very often concentrates gold in these fault lines. Now let's take a look at continental arc subduction. It's very similar. A lot of ocean water goes down with the subducting ocean crust. It mixes with the magmas, picking up gold and other elements, and so you get a lot of felsic and intermediate magmas that are rich in water and rich in gold and other elements. As these water-rich and gold-rich magmas rise through the crust, they become more felsic and intermediate. As these magma bodies push up into the crust, they create many cracks and splits where gold is deposited. And if they come in contact with a layer of limestone or dolomite, they can easily squeeze this gold stuff in between the layers of limestone and dolomite. This is called mineralization. Hey guys, and once again, hot water percolating through these enriched cracks can pick up the gold and quartz and redeposit it into quartz veins. Water will also pick up any residual gold and work it down to the water table over many millions of years, and erosion will expose some of these cracks. Yellow limonite, which is a product of the weathering of iron sulfide or pyrite, is one of the signs on the surface of the ground that prospectors look for to tell them where this mother lode might be. Hey rock buds, here's a quick review. Whether the gold comes from island arc subduction or continental arc subduction, it ends up mostly in gold enriched quartz veins deep in the ground. And here are some samples for your viewing enjoyment. Then weathering and erosion do their thing. Over millions of years, weathering and erosion break up the quartz veins, pull out the gold, and wash it down into the streams. And since gold is many times heavier than sand and gravel, the gold works its way down to the bottom of the stream, and it accumulates, especially in places where the stream flow slows down, like in a curve of a stream, or in an area where the stream widens out and the current gets slow. We are talking about big 1-pound blobs of gold and more. We're talking about gold nuggets, and we're also talking about gold dust, all distributed in the stream bottom. Hey rock buds, most gold is originally found by accident. For example, in 1884, a fellow by the name of James Marshall, who was a mill operator at Sutter's Mill in Colima County, California, was looking in the stream below the mill and found gold that started the California gold rush. A miner with a shovel and a gold pan would dig down to the bottom of the stream where the gold accumulates, pull that stuff up and put it in his gold pan and wash it out trying to find the gold. This is called placer mining, where you dig the gold-bearing gravel right out of the stream and try to wash out everything but the gold. Placer mining was taken to the next level when they built a wooden trough and ran a stream of water through it. They'd shovel the gravel, gold-bearing gravel, into the trough, letting the stream of water wash out the gravel from the gold. Then came major dredging, where they'd put a dredging boat into a stream or river. Backhoe on the front of the dredge would pick up the gold-bearing gravels from the bottom of the stream and drop it on a conveyor belt, which would take it to a separator, and then the waste gravel and stuff was shot out the back end. This way the dredger could crawl through the entire length of the stream, pulling out the gold and basically destroying the habitat. Then there was hydraulic mining to get the gold out of the ancient former stream beds that were now dry land. A very powerful jet of water would wash away the hillside, and all that material would go into a kind of a big sluice box where they would separate out any gold they could find, basically annihilating the landscape in the process. Finally, they commenced with hard rock gold mining, where they dig mine shafts and mine tunnels trying to follow the gold-laden quartz veins, blowing them out with dynamite and hauling the stuff out to these massive quartz hammer mills that would pound the stuff into powder so that the gold could be separated from the quartz. And in some places, like in the Black Hills of South Dakota, where the gold was distributed in very tiny amounts all throughout a particular strata, they did open pit mining, where they just dug the whole mountain up and processed millions of tons of waste rock in order to get a few pounds of gold. Let's look at a couple of examples of fabulous gold finds. During the tectonic orogeny about 470 million years ago, a volcanic island subduction zone developed off the coast of Georgia. Lots and lots of gold was pumped into the ocean sediments between the mainland on the left and the volcanic arc on the right. Then, during the Akkadian orogeny, about 370 million years ago, this package of gold-laced ocean sediments was shoved up on land and became the Dahlonega Gold Belt. The Cherokee Indians knew about the Dahlonega gold, and when Hernando de Soto came looking for it in the 1540s, the Indians steered him away from it. Americans discovered it by accident around 1828 and put it through all the extraction processes that we've described earlier. A total of 1.9 million ounces were removed with a purity of 92%. And now for Cripple Creek, Colorado. Cripple Creek in Colorado is not far from the famous Pikes Peak. And the folks on their way to the Colorado mines would say Pikes Peak or bust. And most of them were bust by the time they got done. Hey, remember that during the latter part of the Laramide orogeny, the flat plate subduction system broke down, and this created a wave of stratovolcanoes erupting from east back to the west. One of these volcanoes at Cripple Creek came in contact with a tremendous amount of water. This caused the whole volcano neck to explode and crack into millions of pieces, creating what geologists call a breccia pipe. It's very porous. Later on, more water-rich magma welled up and squirted gold into this breccia pipe, creating Cripple Creek, by far the biggest gold-producing area in Colorado. While they were doing hard rock gold mining in there, one day they came across the mother lode. Hard rock gold mining was followed up by open pit gold mining. And here are some samples of Cripple Creek gold for you to look at. Cripple Creek produced 3.45 million ounces of gold that was 75 to 95% pure. Okay, most excellent rock buds. That's it for the Geology of Gold. Hope you liked this video. Thank you so much for watching. If it was good, please subscribe. And this is your Rock Papa wishing all my excellent rock buds happy rock hunting. Papa out.